This is 2.4 practice, page 122. Basically, you want to sketch these and sketch them as an absolute value. So this is f of x, absolute value of f of x. So the positive part will stay the same, but wherever it turns negative, that will turn up and be positive instead. Okay. Number 6, same idea here. Wherever it's positive, it'll stay positive. If anything's negative, it'll be up there instead. Number 9. So once again, if it's positive, so right there at 2 and out, it'll stay positive. And at -2, okay, but the other part will reflect and make it positive. Okay, absolute value always makes things positive. Okay, number 12. How does the graph of f of x compare with the graph of absolute value of f of x? Okay, if you think about it, f of x is x squared is equal to this. Absolute value of that would just turn anything negative to be positive, but there isn't anything negative, so they will stay the same. Okay, number 15. The range of f of x is this. What is the range of absolute value of f of x? Okay. So range are your y values. So if I have y values that go from -infinity up to -2, right? So I have range values here. But we said absolute value can't be positive, can't be negative, right? They're turned them to be positive. So they would go from there to there instead. Okay? So the range would then be from 2 to infinity. Instead of the negative, it turns them to be positive. Number 18. We want the domain of range of that and of the absolute value of that. Okay. Number 18. Y-intercept is 2. Slope is -1/2, so it goes down 1 over 2. You can also use Desmos to graph that if you need to. Okay, so there's our graph. Our domain of this is going to be all these x's, okay, all real values. And the range, all these y's and all these y's. So the range is also all real numbers. Okay, now the absolute value of this. Okay, so remember anything that is negative, which would be this part here, will reflect to be up there. So a graph it looks something like this. Okay, so come down here and then reflect up there. Okay, so if you think about the domain for this one, all these x's and all these x's are included, so all real numbers. Now the range, our range, we can't have any negatives, right? So we can have 0, and we'll have the y's that are greater than 0. Or from 0 to infinity is another way to write it. Okay, 21. I don't know if you could see that last one. I didn't look up to see. Okay, so it comes down here and goes up here to be positive. That's your absolute value. Have all of our x's, but only y from 0 through infinity. Okay. Number 21. A graph of the line is given. The domain. Find the domain and range of f of x of this. Okay. So I like this one. So our graph looks like this. That goes to -2 there. This goes to 3 here. There's that -2 there and up to 3 there. Okay, so the original graph, our domain nothing below or above there, goes from -2 to 3. And the range goes from -2 to 3. Okay, now the f of x of this, and the absolute value of this, okay, this part stays the same. But this part, all this negative, has to reflect up to be positive. Okay? And that would be a height of 2 because I was down at -2. So if you think about the domain of this, would be from -2 to 3 again. And the range goes from 0 all the way up to 3. Number 24. Okay, just the same thing, just a different graph here. So our original graph, okay, that goes out to 3 and goes down here to negative 3. So once again, our domain goes from negative 3 to 3. And our range, this goes down here to negative 3, and this goes up here to negative 1. So our range is from negative 3 to negative 1. Okay, now the other part of it, okay, so anything that's negative, so if this is at negative 3, the output of it would be a positive 3. So basically it looks like this, because anything negative is flipped up to be positive, okay? So this is down here at negative 3, so the top here is going to be up at positive 3. And this was at, I don't know, it doesn't really matter, but negative 2, I guess. So this would be up at positive 2. And it would be straight over till 3 again, okay? So if this bottom peak was at negative 1, it would be here at positive 1. Okay, so our domain goes from negative 3 all the way through to positive 3. And our range goes from 1 to 3. Okay, 27. Okay, so one of these two is f of x, and the other one is the absolute value of f of x. Okay, think about which one's which. Okay, part A versus part B. Okay, notice absolute value would be the reflection up above, right? Because you can't have negatives with f of x. I mean, with the absolute value. So this one has to be the f of x, and the only positive one has to be the absolute value of f of x. Okay, number 30. Okay, part A, we want to know where they're equal to each other. So they are equal to each other right where they cross each other here. So x is 0 and x is 8. So x equals 0 and x equals 8 for part A. For part B, where is the y of 1 less than the y of 2? And here's our y1 and here's our y2. So thinking back to last chapter, right? Our y1 is less than y2 down here and down here. So this would be from negative infinity up to 0. It's or not or equal to, so open. And it's also less, y1's less over here, so from 8 to infinity. Okay, part C, where is the y1 greater? So y1 is greater from here to here. Those are greater than the other line there. So from 0 to 8. Okay, so your answer would look like this. Okay, 33. Okay, we have these graphs here. Which graph is that of y is equal to f of x? How do you know? So is it this one or this one? Okay, we know that the f of x is the one that's always positive, is the negative one. I'm sorry, no, the f of x is my absolute value one. So absolute value one would be the one that's not negative. So f of x is the V-shaped one, not negative. Okay, so the one that starts like a V is the absolute value one, the one that does not go negative. Okay, number 36. So it tells us to solve where is f of x greater than g of x. Okay, so my f of x was this one, and where is that greater than the g of x? Okay, so here at 1, I know they're equal, and then g of x is greater on this side, right? But on this side over here, my f of x is greater than this g of x. So from negative infinity up until 1. Oh, I'm sorry, that isn't 1. We can see the intersection's at 8, 10. So that's 8 right there. So from negative infinity till 8. Okay, so that's 36 from negative infinity up through 8. 39. Now we're getting into solving them. Okay, so we're going to solve them. We have the x plus 4 is equal to 9. X plus 4 is equal to negative 9. This is part A. So we get x is equal to 5 and x equals negative 13. Part B, x plus 4 has to be greater than 9. X plus 4 is less than negative 9. Remember, go LA. So if it's a greater than, it's an or statement. Okay, so we have x is greater than 5. X is less than negative 13. Okay, graphically, negative 13 is lower, 5 is higher, less than this one, greater, x is greater there. So since it's an or, we have all these numbers and all these numbers as our solutions. Part C, less than 9, and x plus 4 is greater than negative 9. Since it's less than, it's an and statement. Subtract the 4 over. Graphically, greater than negative 13, less than 5. Where is it true for both this one and this one? All these numbers in between here, it's true for both. Okay, 42. Sorry, you couldn't see that too well. Okay, there's 42. So the first one, negative 9 minus 3x equals 6. Negative 9 minus 3x equals negative 6. Solve them. Add the 9 over to the other side, makes 15. And divide gives you negative 5. Add that over, gives you 3. Divide gives you negative 1. So you have negative 5 and 1 as your other two answers. Part B, negative 9 minus 3x greater than or equal to 6. Negative 9 minus 3x is less than or equal to negative 6. And since it's a greater than's an or. Solve it. And when I divide by a negative here, by negative 3, I have to flip that sign. And I divide by a negative 3 here, I have to flip that sign. Okay, so I have negative 5 and negative 1. X is less than negative 5 or equal to. X is greater than or equal to negative 1. And since it's an or, it's all these numbers less than here or greater than there. And part C, and since it is a less than, it's going to be an and. And divide, switch the sign. Divide, switch the sign by negative. Greater than negative 5. Less than. I shouldn't have switched that sign right there. Less than -1. So it's all those numbers in between there. 45. It's hard for me to be able to get you guys to see it all. -0 and 0 are the same thing. So 5/7 for both answers. So this is one case where you don't get two answers. When it's equal to 0, you just get the one answer. And the second one, flip the sign and you make it 0. Flip the sign when you're dividing by a negative. Okay, so if you're looking at this, we have 5/7 is our one answer there. And, okay, it's a greater than, so it's an or statement. So it's less than or equal to, and it's greater than or equal to. So we get a graph like this. Now, as an or statement, what numbers are less than 5/7 and or greater than 5/7? Where is it true for both? Okay, it would be true for all numbers. Okay, so our solution would be all real numbers. Every number works there. Okay, so 5 minus 7x is less than or equal to 0. Switch a sign, -0, same thing. You can see there, yep. Switch a sign when you're divided by a negative. And this would be an and statement. So greater than or equal, less than or equal. Okay, so as an and statement, both things have to be true. What numbers are greater than or equal to 5/7 and at the same time less than or equal to 5/7? The only number is 5/7. Okay, that'd be the only answer for that one there. 48. Okay, so we want to solve this. Okay, I think I forgot to do this in the notes. I got to remember to put that in here. Okay, so the first thing we want to do is get our absolute value by itself. So to do that, before I set up the two equations, I'm going to do this. Okay, now I have absolute value by itself. So now I can set up my two equations. 2x plus 4 equals 8, and 2x plus 4 equals -8. Okay, 51. Okay, so once again, we want to get the absolute value by itself. So you could do a couple of things first. You could divide by 1/2 on both sides. Let's actually just multiply by 2 to get rid of the fraction. So if I multiply by 2 here, that cancels out. And this would give me 3/2. Okay, now I can set up my two equations. Okay, and I work it out there. Subtract a half from that gives me 1. So x equals -1/2. And then one. Okay, so you find your two answers there. 54. Okay, here's 54. We've got inequality, so we set up our two equations as 3x minus 1 is less than 8. 3x minus 1 is greater than negative 8. And since it's a less than, remember, go LA. It's an and statement. Okay. Add the 1 over and divide. Add the 1 over and divide. Okay, so if you look at the graph, negative 7/3 and 3, it's greater than this number. It's less than 3. So as an and statement, both have to be true, so it's everything in between. If you want to write it in interval notation, it would be this. 57. Once again, two equations. 3 minus 2x is greater than 1. 3 minus 2x is greater than 1. Sorry, less than. Flip the sign when you make it a negative 1. And it's greater than, so it's an or statement. Subtract that over. Divide by negative 2. When you divide by negative, you flip your sign. Subtract that over. Divide gives you this. Okay. And we have 1, we have 2. It's less than 1. It's greater than 2. It's an or. So it's all these numbers and all these numbers. In interval notation, it's from negative infinity to 1. And it's also, this means a union as well as, and, from 2 to infinity. All right, number 60. One half x minus 2 is greater than negative 1. 1 half x minus 2 is less than negative 1. So, yeah, I'm going to add the 2 over and multiply by 2. Add the 2 over. Sorry, this should be a positive one, right? Flip the sign and make it the opposite. So add the 2 over gives me 3. Multiply by 2 gives me 6. Okay, so, and it was a greater than. So it's an or statement. Okay, so greater than 2, less than 6. Okay, there's our graph. And since it's an or, it's all of these or all of these, which means it's going to be all real numbers. 63. Negative 2x plus 7 is less than or equal to 6. And negative 2x plus 7 is greater than or equal to negative 6. But you know what? This is a positive number, right? Can I have any positive numbers that are less than a negative 6? Nope. So hopefully I realize that and I don't have to work it out. 66. Okay, so we had done this in our class here, in the notes. When we have two absolute values here, we have to set one exactly how it is. So you'd have the ax plus the b equal to the cx plus the d is one equation. And then the other equation, you have to do the opposite of it. The ax plus b is equal to the opposite of the cx plus d. 69. Okay, so here we actually have to work this out here. So we have the negative 2x plus 5 will equal the x plus the 3. And the other equation is negative 2x plus 5 has to equal the opposite of the x plus 3. You can't see it though. Okay, so equal the opposite of it. So I'm going to add that over, subtract that over, and gives me my answer, 2/3. and that would be negative x minus 3. And if I add that over and add that over, so we get 8 and 2/3 are the two answers. 72. Okay, I'll just write it down here and then show you my work. So one of them is equal to the original, and the other one is equal to the opposite of 1/3 x plus 8. Okay, let's multiply it all by 3, just get rid of all the 1/3 there. So 3x plus 9 is equal to x plus 24. Okay, subtract that x over, subtract that 9 over, and I get 7.5 or 15/2. And distribute the negative through, then multiply it all by 3. 3x plus 9 is equal to negative x minus 24. So add that over, gives me 4x. Subtract that over, gives me negative 33. And x would equal negative 33/4. Okay. 75. I'll write it down and then come back and show you. Okay, so we have our original and then equal to the negative. I'm going to subtract the 1/4 over here to give you 1/2 or 0.5. And add the 3 over and multiply by 2. So adding that over gives you 1x. Subtracting that over gives you 2. X equals 2 and 8. 78. So equals the original, and then equals the negative of it. Okay, so add that over, and they cancel out. So I have negative 6 is equal to 6. And then I have okay, I'm sorry. 12 over it would be 6/5. Okay, and this one here, subtract that over, I get negative 6 is equal to negative 6, which is true for all numbers. Okay, so this is one where we might want to look at a number line here. We know that 6/5 work, and we know that all numbers work here, right? So if we look at this, let's just pick a number and see if it works. Okay, let's pick like 0. If I plug a 0 in here, b0 is negative 6. Plug a 0 in here. Okay, it's absolute value. Plug in absolute value of both sides. So plug a 0 in there, b0 be negative 6. Absolute value of negative 6 is 6. 0 plus 6, absolute value of 6 is 6. Plug in a 10, it'll work. Yeah, so every number will work here for the 78. 81 is our last one. Okay, I want you to do this looking at the graph. Okay, I'm going to pause it and look at Desmos for the graph. Okay, this is what the graph looks like in Desmos. Put this into the one side, gives you this graph, and y equals 8 in the other side gives you this graph. We know where they're equal to each other. So you can see that x equals -2. And over here, right there, x equals 6. And that was the end of that long assignment.